Hi, I'm Benny D, and in this video we're going to look at solution of literal equations and systems of equations. So remember, solutions to literal equations will be in terms of constants, not numbers. Okay, so we're going to have a look at a couple of questions and examples that relate to literal equations, and then I've got an example of a system of equations question. So our first example here is we've got solve x squared plus kx plus k equals 0 for x. Okay, so we need to be thinking about this and going, I need two numbers that multiply to k but also add to k. Well, that sounds quite challenging. Okay, so the easiest thing for this would be to jump straight into the general quadratic formula, which is negative b plus or minus the square root of b squared, take 4ac over 2a. So we find then that x equals, or negative b is actually, in this case, negative k, plus or minus the square root of k squared minus 4 times 1 times k, all over 2. So x is going to equal negative k plus or minus the square root of k squared, take 4k, over 2. Okay, we can't actually simplify that anymore, so that would actually be our answer. Okay, we do need to be a little bit careful here though, okay, because we'd be caring about, now it's not explicitly stated here, but we care about real solutions, so we just need to be a little bit careful, because we could say, well, k squared take 4k must be greater than or equal to 0. Okay, so if we factorise that, we've got k outside of k take 4. K is greater than or equal to 0. So we'd be saying that k would need to be greater than or equal to 4, or k would need to be less than or equal to 0. Okay. So these are our solution, like this is our solution here, but we need to be careful and actually define what values of k that we're allowed to actually use here. Okay, in our second example, we've got solve x cubed minus 3x squared, 3ax squared plus 2a squared x equals 0 for x. Now for this one, we can see that x is actually a common factor of all our terms here. So we're actually going to take x out as that common factor and go x outside of x squared, take 3ax plus 2a squared equaling 0. Now, if we're going to factorise that, we need to think, okay, I would need my two brackets, okay, and I need to be thinking, I need a number that can multiply to negative 2a squared and add to negative 3a. Well, we can see we must have an a and an a. Now, because this is positive and this is negative, they must both be negative. Okay. And the only other thing we need to think about is our factors of 2, okay, which are 1 and 2, which do in fact get us to 3. Okay, so if we just need to double check that, okay, if we're going to multiply it out, we go x times x is obviously our x squared, x times negative 2a is negative 2ax, take ax gives us negative 3ax, and then negative a times negative 2a gives us positive 2a squared. So that does in fact work. So we can say, therefore, x equals 0, x minus a equals 0, or x take 2a equals 0 through the null factor law, which means when we rearrange these, that we get x equals 0, x equals a, or x equals 2a, right, for our solutions. Now we've got one more question we're going to look at as an example. Okay. And we've got find the coordinates of the points of intersection of the parabola y equals x squared take 2x take 2 and the straight line y equals x plus 4. Okay, so if you're thinking about what that looks like a little bit, okay, we've got this parabola here. It actually looks something like this. Okay, we know we go through negative 2, okay, for our y-intercept, and then we've got the straight line that is y equals x plus 4. Okay, so we're going to do something like this. Okay, so we're going to intersect and we're going to intersect. So that's what we're trying to find. We're trying to find those points of intersection. Okay, the way that we do that is essentially solving them simultaneously. Okay, but often we don't think about it because we just do the substitution straight away. Okay, because we know y equals this and y equals this. So that's 4. Okay, we just set them equal to each other. Okay, we very rarely answer these type of questions through elimination. Okay, rearrange, we get 0 equals x squared, take 3, x, take 6. Okay, now we need to be going, okay, I want to factorise this. Factors of 6 that add to 3, well, we don't really get any nice ones there. Our factors look like they're going to be a problem. Okay, so again, it looks like it's going to be a problem. I jump straight into the general quadratic formula. Now you can always double check this before going through with it and go, hey, are there going to be solutions or not? Have a look at the discriminant here. Okay, well, I've got b squared, well that's 9 minus 4 times 1 times negative 6. Okay, well I've got 9 plus 16, well that equals 25. I'm going to be okay here. Okay, I'm going to be, sorry, not 25, what am I saying? That's not 26. Sorry, that's not 16, what am I saying? That's 24. Okay, so that's going to equal 33. We're still going to be fine. Okay, it's a positive number, so we're going to have solutions. You've already done half the work now. Okay, negative b is positive 3. That makes it. Plus or minus the square root of, we don't need to work this out, we just did. It's 33 over 2 times a, which is just 2. Okay, so we'd have a 2x values here. So we've got x equals 3 plus root 33 on 2, and x equals 3 minus root 33 on 2. Okay, we can't say job done because we want to find the coordinates of those points. Okay, so what we need to do is sub these back in. Now you could be going, oh god, that looks awful, subbing this back into our equation here, but don't sub it in there. Okay, sub it into this one. Much nicer. Okay, because it doesn't matter which one we sub into, it's gonna work out fine. So our first one, we get y equals x, x, which we're going to say is this one, 3 plus root 33 on 2 plus 4. Okay, well let's make that 4, 8 over 2. Okay, so that we can actually get one fraction here, get 11 plus root 33 over 2. So that'll match up with this x value here as a pair of coordinates. I'm running out of room, so I won't write it all down. Our second one will be 3 minus root 33 over 2 plus again that 4, okay, which again we'll write as 8 over 2. Bring it together, we're going to get y equals 11 minus root 33 all over 2. And that would match up with this x value here, and we need to write them as coordinates. Okay, because it says find the coordinates, so we need to state the answer in our coordinates. So it'll be those two together, okay, and these two together. So look, hopefully that'll be enough to get you through some of the questions on this work.